IP Harwal Polymer, Interplast Group, and TSSC Building Material Division. Also an advisory board member for UTech, MEFPU, and ASD Expo 2025. Please join me in welcoming him to the stage for his presentation.
Yes, good afternoon. Today my topic is about water-blown spray system. Any idea why I chose this topic from the audience? Yes, because good news, 141B is phasing out, and we as system houses will be restricted to use 141B. So water-blown system will be one of our possible alternatives. And I want to tell you that this is not the best replacement for 141B, but it's one of the options. And in this discussion, I'm going to talk about the benefits, the advantages, disadvantages, and I'll show an introduction. So just an overview of our presentation. I will introduce our group, then I'm going to discuss about how the spray system works. Then I'm going to talk about the challenges and the considerations when using water-blown system. Then I'm going to introduce our water-blown systems, which is developed in our division in Interplast, Harwal Polyurethane. Then I'm going to do a case study where I'm going to compare the cost of the 141B and the relative application cost. So you guys will realize that it's not only the cost that matters when you apply the foam. And I will finalize my presentation with the key takeaway points. Just a quick introduction. Harwal Group is a multinational company all over the world, global company. And IP Harwal is one of the divisions within Harwal Group. As you see from the picture, it's all over the continents, in US, in Europe, in Russia, and mainly here in GCC. And this division actually was born in 2009. When I first came here, the owner, Mr. Miro Donabedian, told me, Miro, we need to make foam. And that was his command to me. And then I'm standing here after almost 16 years. And from nothing, we became a full-fledged polyurethane system house. The group makes about 46% of its products in building materials. And our application today is about spray foam, which falls into this category. This is Mr. Harwal Donabedian. He was the guy who told me 16 years ago, Miro, go and make foam for me. That was his command. And we started first with our panel industry, and then we diversified. And now we are covering the entire spectrum of the rigid foam, as you will see. And as you can see in this, innovation is our culture, and Harwal Polymer is one of the divisions within the Harwal Group. Our spray polyurethane system, our products, as you can see, is all over diversified, and our focus is the first one, spray foam. And this is the factory, which is right now in Dubai Investment Park, and we are fully integrated. We have a reactor that makes polyester polyol as well. We recycle also rigid foam. We recycle PET plastics. So we make our own polyester polyol, as well as we blend this polyester in our own formulations. So what is spray foam in basically? It's two components, A and B. One is the polyol and B is the MDI. And when you mix those two in a machine, a high pressure machine, you will get the spray foam. As you can see here, like the volume will expand from 30 to 120 times. And in our application, which is water blown, the main gas in the cells will be carbon dioxide. And here's a small video showing like, oh, sorry, it's not, the video, I don't know why it's not working. Anyway, it's the video. This is the spray. So this is a water blown spray right now applied on a roof in Dubai, in a high temperature case, almost 50 degrees, hopefully on the side. As you can see, like we have open cell and closed cell. Today our focus will be mainly on the closed cell because that's where majority of our customers use the closed cell system here, especially in housing industry for insulating the roofs. But open cell is also an option for other applications where it is not that critical, the compression value. They just want something to fill the area. The benefits are it has low, it doesn't shrink because it's open, and it's cheap and it's low density. Evolution of the blowing agents, as you can see from left to right. Right now we are phasing out the HCFCs and HFCs, and we are entering into this new era where we are going to the HFOs and the CO2. And in my case, I'm going to be talking more about the CO2, which is the gas used in the water-blown systems. Blowing agents, there are two categories. One is the one that you add in your blended polyol, like the 1,4-1Bs, the HFCs, the HFOs. The other one is the blowing agent is produced during the reaction, which is our water-blown system. So the CO2 from the reaction produces the blowing effect. And it has a big influence on the dimensional stability as well as on the thermal conductivity, as we will see later on. My previous colleague, he was showing the effects of the gas on the thermal conductivity, which is very important. 60% or 70 is mainly coming from the gas in your insulation. So what type of gas you use has a tremendous effect on your insulation value. Here is a comparison between the 1,4-1B, the HFCs, the water, and the HFO. One distinct factor that you can see in the bottom, the conductivity of the water-blown system is 16.6, which is way higher than 1,4-1B and HFO. So this is a disadvantage for the water-blown system. The good thing is that the GWP and the ODPs are one, so there is no effect on the global warming or the ozone depletion. So if I compare the conventional systems, the HCFCs, the HFOs, and the water-blown systems, what are the main points? The water-blown system, there is no fluorine in it, so if you want zero ODP and one GW and no effect on GWP, then water-blown scores the best. It's cheaper than the HFO. It has low hour value, but it's not as good as the others, like the 1,4-1B and the HFOs. And the performance is mainly dependent on the density. If you drop the densities, then it's not going to perform as good as the others. And it is best fit for applications where you look cost savings and GWP avoidance. This is a comparison between, again, the three systems in a more complex way, taking different criterias. Areas where it is not performing well is the dimension stability. If your density is low, definitely you will suffer. The closed cell content is not as good as the others, like the HFOs and the 1,4-1B. And the thermal performance from the baseline already, it's not good. So these are the disadvantages of the water-blown system. Also, the processing sprayability on the field. If the applicators are not favorable, are not experienced using water-blown system, then you will have problems. You cannot apply the same way that you apply a 1,4-1B system, so your applicators has to be trained how to use the water-blown spray system. And the best fit for water-blown system will be applications where the R value is not critical. They are looking for a green solution and a cheap solution. That's where the water-blown will be ideal. If you're looking for efficiency and insulation, then you have to opt for alternate solutions like the HFOs. Practical notes, regulatory reality, we know that HCFC is phasing out and it's going to be restricted, so we have to shift. By the end of this year, we'll be in trouble. Performance versus sustainability trade-offs, the R value is not as good as the HFOs. It's a cost effective, so if you want a cheap solution, then definitely water-blown is cheap on a drum-to-drum basis. The system design matters. You can have a good water-blown system, and you can have a poor designed HFO system. So just because it's water-blown doesn't mean that it's a bad system. And the life cycle cost, the HFO system typically raises the material cost initially, but on the long range, it will serve the life cycle cost as long as the installation is critical. Very quick comparison between again, all the three systems. The typical cost impact for the HCFC is low, but it's phasing out. The HFO is high, it's premium chemistry, but the water-blown is low cost. So from a cost perspective, again, the water-blown system is good. What are benefits? It sticks, you don't need to apply any glue, strong adhesion, seamless and joint-free. Acoustics-wise, it helps. And it has good thermal insulation value, but again, not as good as the HFOs. Environmental regulated advantages, you have all the environmental requirements. It will meet the LEED, the BREEAM, the Estidama. LEED is becoming more and more required by our consultants. The Estidama is the mandatory in Abu Dhabi. So from the regulatory point of view, the water-blown system is good. And spray foam, what's the advantage of spray foam? It saves energy. As you can see in US, more than 40% of the energy demand goes to building sector. And in the building sector, you have 40% of energy used in buildings is for heating and cooling. So if you use spray foam in buildings, you can definitely save energy and save AC costs. And definitely comparing to all other installations, spray foam is the best value in terms of R values. What are the challenges? For the water-blown system, definitely shrinkage is a problem if you don't have the right density. Application conditions on the site is a problem. If you're not having a clean floor, if your applicators are not trained enough, you will have problems. And reliable sourcing of the system components are very important. And from a sustainability point of view, the HCFCs are phasing out. Water-blown system is eco-friendly, but it has its own challenges in terms of density and thermal conductivity. And definitely, like the standards in the area are driving growth. Sidama is requiring strict insulation values. Dubai municipality in Dubai, they have a strict U value for the roofs. So there is a growing demand for green products in the region. These are our Harwal products. The columns which are green are our water-blown system. We have a low density and we have a high density, and we have the open cell system. The most important thing is you look all the way to the bottom where the physical properties are. You can see the R values. The R values are again lower compared to the 1,4-1B and 1,4-1B system, as well as the thermal conductivity. You can see that the thermal conductivity of the water-blown systems are higher. This means that you need to apply more thickness of foam to match your R values. This is just from a performance point of view. The ratings, I would say one important factor is also like the storage and handling, which is not mentioned in the previous graphs. When you go to HFOs, how are you going to ship those systems to your site in Dubai where the temperatures are 50 degrees? My friend Amanullah mentioned that they are using thicker drums, less material inside. So these are transportation challenges that you are going to face. Are you able to spray these in the hot temperature on the site? We have to find out. I don't have like real experience right now with HFOs, but I would say that by next year we'll have a very good idea the main challenges using HFO. But in terms of water, you don't have a problem. You just send your drums to the site like 1,4-1B. Even 1,4-1B, sometimes we have problems where customers will say your drums are bulging because it stays outside 50 degrees. But for the water-blown system, we don't have this problem. And the cost is also less, so that's another advantage that you can take away. But the dimension stability is a challenge. Now, this is a case study which I did. The numbers are not 100% because some of them are estimations, but it gives you an idea if you want to match the U value of a HFO system, a 1,4-1B system, and a water-blown system. Off the bat, the thermal conductivity of the water-blown system is 25% higher, so you have to compensate for that. Then, definitely for dimension stability, you cannot inject the same density. definitely you have to inject more to ensure that your foam doesn't shrink. So there is another 25% premium on density. So taking these two into consideration, then the foam density should be 30% higher compared to make sure that you are compensating for the density. So if we consider a U value of 0.3, right, that means that on a per square meter of foam that you need to apply 41% more material to match the density, to match the U value of your system compared to 1,4-1B or HFOs. So 41% more you have to inject material-wise to compensate the U value. Now, the cost. Yes, we know that the water-blown system is cheaper. Okay, compared to 1,4-1B, it is cheaper, and HFO is 9% higher than 1,4-1B. So the reference point is 1,4-1B. HFO, I am assuming, is 9% higher. The water-blown system is 11% lower. So if I take the material that I'm putting more and I'm factoring also the cost that I'm going to save by using water-blown system, still the water-blown system is 25% more expensive per square meter applied compared to 1,4-1B, and the HFO is 10% higher to 1,4-1B applied. So basically, compared to HFO, there is about a 15% difference more. So if you are trying to achieve a U value, then the water-blown system is not the right material to use, because you are going to lose on your applied cost. So that's what I want to highlight here. Applications, as you can see, you have a lot of applications. For Dubai, for example, an excellent application will be to use on the roofs. All the roofs are leaking, so all they care is, Miro, give us something to stop the roof leaking as well as improve our insulation. Water-blown system is an excellent way of using you on your roof, because there is no project requirement saying I need U value of 0.3 or 0.12. So using waterproofing your roofs is an excellent way of using water-blown system, or in cold stores also, and the wall applications. Also for cold stores in the floor, for swimming pools, for tanks, for LNG tanks, this is where you can use the water-blown system. Oh, what the hell? I am audible. There's a small technical problem. Okay, key takeaways. So what are the key takeaways? The best fit for cost-sensitive projects, use water-blown, because it has the lowest F-gas footprint, and insulation value is not critical, then use water-blown system. It's diverse applications, especially for applications where you don't have site temperature problems or transportation of your material to the site, because imagine shipping your system from here to Saudi Arabia on a trailer. Definitely your drums, if they are not properly designed, and then they will bulge. But with water-blown system, you don't have problem with the transportation. It is a sustainable and innovative solution that will replace the HFC and HCFC. And the market trend is basically to go green. So definitely the GCC is shifting towards green systems. So water-blown system is a good alternative for the application. Our value proposition, we have expertise in insulation and cladding. We have a proven track record of matching U values for our clients, and we deliver eco-friendly and high-performance solutions, and our booth is right there. And whoever is interested in our products, you are more than welcome, and we can give you some gifts. And you can tell Miro, send me here, and we'll have some giveaway for you guys. And thank you for your participation. I hope it was interesting and value added. Thank you. Sorry, I ran out of time.
Thank you, Miro sir, for that insightful presentation. Let's take a quick moment to check if there are any questions for him from the audience. All right, sir. Thank you so much. Thank you.
Thank you.
We now move on to our next session, a panel discussion on greener fields